Hello everybody, welcome back. We're now going to do the three problems over again that I demonstrated manually, but this time we're going to use our calculator. Now I have the TI-83, which is a little bit different than TI-84, but essentially the screen is going to look the same and we're going to pursue these hypothesis tests the same way. All right, so we're going to do the two-tailed test for testing for the population mean. That's the one that involved the mean annual tuition and fees in the 2009-2010 academic year for a sample of 14 private colleges. In California was $30,500 with a standard deviation of 4,500. Box plot shows that it's reasonable to assume that the population is approximately normal. Can you conclude that the mean tuition and fees for private institutions in California differ from $30,000? Test at the 5% level of significance. But this time, instead of showing all 5 steps, we're going to use the p-value method, meaning we're going to use our calculator. Now, remember, and you may have to look back in your notes, that the null hypothesis says that the population mean income is 30,000 bucks, whereas the alternative statement, which was the claim, said that the mean annual income was not equal to $30,000, and we were testing at 5%. To do this test on your calculator, you hit your stat button and go over to tests, and then you go down to t-test. So stat, test, t-test. Dive into t-test, and we always select stats because very rarely do we type in data, raw data into a list and have our hypothesis conducted from that source. So type in stats, go down to mu sub 0. Mu sub 0 is the purported population mean under the null statement, which in this case is $30,000. X bar is the sample mean, which in this case is $30,500. The standard deviation of the sample for this example is $4,500. The sample size was 14. And we have a choice now whether we're conducting a two-tailed test, a lower tail test, or upper tail test. If you look at your alternative hypothesis statement, which has the not equal to symbol, this is a two-tailed test. So you want to select two-tailed test, moving your cursor right here and then hitting enter. We'll select it and then go down to calculate it. We're ready to conduct the t-test here. Calculate this, and here you go. Now, what we're interested in is the p-value. Notice the test statistic, which we computed when doing the problem manually, showing all 5 steps. It was 0.4157, blah, blah, blah. That's your test statistic. The p-value is 0.684. Now, 0.684 is very large. That's a huge p-value. Notice that's much greater than our level of significance 0.05, the level that we were testing these hypotheses at. Because our p-value is greater than our level of significance 0.05, we would conclude that we are unable to reject the null hypothesis, or we do not reject the null hypothesis because our p-value is too large. And notice that was the same conclusion that we gathered by doing the problem the manual way, the critical value method, by showing all 5 steps. We were also unable to reject the null hypothesis, and so the claim that the mean is not equal to $30,000 is just not being supported by sample evidence. Again, we cannot reject the null hypothesis because our p-value, 0.684, is much bigger than our level of significance alpha, which is 0.05. That concludes this test done the p-value way.